because that means that the Steelers still have the most Super Bowl rings. All right, we had page 31, 32. Is that what it was? Page 31 and 32 was asked to be completed. So if you get that out, please, I'll come by and mark it off. All right, so let's, I'll run through that assignment. Make sure your phones are away, please. So before we hit 31, 32, one, I have graded your tests, and they're in the grade book, or your quizzes. You did better than you had. So if you owe me the quiz because you were absent, you have until, so right now it's counting as a missing, but it doesn't count against your grade. So you'll need to come in and see me. Let's see. I will not be here on Thursday. I will be at State DECA as a judge, so wish me luck. It's a business thing. So it should be good. But that day will be the take-home test. So it is your responsibility to come in by Wednesday. So either before school, during first period, or during fourth period, or if you have third or fifth period that you're off, you can come to my other classrooms and take that. So Kat, you need to take one, okay? Chloe, you need to take it. Samantha, you need to take it. Armin, you need to take it. Jake, you got to take it. Miss Decker, you need to take it. Jacob, you need to take it. And Brian's not here. Cool. Good. And here we go. Taking a look at that page, a couple of you said you had questions on some of the problems. So let's take a look at it. Page 31, 32. Front page, 1 through 4. Was it 4 you guys said? Number 4. It's t at x. Okay, item 1, is it exponential? Yeah. Oh, sorry. Didn't mean to forget you. Some markers? Is it linear or is it exponential? Linear. It's linear, right? So, what's my y-intercept? 10. So from that, I'm going to go down 4 and write 3. Let's see. It just said sketch a graph. That's all we had to do. Okay, we'll figure out what your error was. Number 3 as well. Number 3, r at x. Okay, linear or exponential? Exponential, it's raised to an x, right? So what is my asymptote? 1. Everyone okay with that? All right. Too much talking. Put your phone away, please. It's rude. It's rude. You know it is. Thank you. All right. So let's figure out where it crosses the y-intercept. Ready? Plug 0 in. 2 to the 0. So this whole thing becomes 1 right here. Negative 2 times 1 is? Negative 2. Negative 2 plus 1? Negative 1. 0, negative 1. Right? And then second point, plug 1 in. 2 to the first? 2. 2 times negative 2? Negative 4. Negative 4 added to 1? Negative 3. So this looks like that. Is it growth or decay? It's growth, because as we go to the right, we go away from our asymptote. Okay? All right, go to the second page. So page 32 says determine it as linear or exponential. If linear, identify the y-intercept and the slope. If exponential, identify the y-intercept growth factor in the equation of the horizontal asymptote. So questions on any of those? 5 through 14. Yeah. 9. So number 9, we have this graph that looks like looks something like that, right? Definitely exponential. Agree? Yeah. Growth or decay? Decay, because it comes to the axes that go to the right, so it's decay. Okay, exponential decay. Our horizontal asymptote, which we call ha, is this line right here, so that's y equals 2. Remember, y equals a number is a horizontal line. And then our growth factor. First one. It's going to be a long day. The growth factor, let's see. You know what, I'm not able to identify 2 points on that, so I would, actually, let's that, is that negative 1.5 looks like it works. And 3. All right, what does my growth factor appear to be? If I can identify negative 1.5. Yeah.
Define the where is that? How you got 2?
My y equals 2?
Yeah.
That's my, makes a horizontal line. That makes that. So when I looked at my picture, it appeared that it goes right along that horizontal line. So let's see. Drop down 2. I don't know. I'm not going to worry about the growth factor on that. I'm pretty sure I won't give you the growth factor when you're looking at a line. I would give you the growth factor if you had, like, number 5. The growth factor would be 5 over 2.
On the quiz we took, it asked for the growth factor. How would we?
On our quiz that we just took,
Yeah.
it did not ask for the growth factor. It asked for the slope.
It asked for the growth factor on the exponential.
I didn't grade that. The graphs. Average rate of change, average rate of change. Nope, I don't have a growth factor. Asked if it was growth or decay, linear, exponential. Average rate of change is what it asked for. No growth factor.
What is the average rate of change? Would that be?
Average is the slope between 2 points.
So the slope between those 2 points.
Yeah. Be 3 minus 5, 0 minus 1. Over that. Cool? All right. Passing forward, make sure your names are on those, please. And if you're handing in anything else late, please hand those forward. Yeah. Yeah. Right there. All right. So I'm going to ask y'all a question that you might have heard this before, and please don't spoil it if you have heard it. But so let's say I would like to hire you to do a job, and this job is going to take 30 days to do. You still with me in this adventure? I don't know what the job is. Yes, you get paid. So I'm going to give you a choice. I'm going to give you a choice between a method of payment. The first method of payment is I'm going to say, I'm going to give you $528,000 for 30 days worth of work. Now, I don't know what the job is that I'm going to give you. Or I would offer you a penny the first day, and I'd double it every day for 30 days. Okay? So that means that you get a penny the first day, you get 2 pennies the next day, you get 4 pennies the third day, 8 pennies, 16 pennies, on and on and on. You want to take the $528,000 up front? Or will you take the penny a day doubled each day? What do you think?
Penny a day each day.
So we have two different answers, right? Yeah.
Isn't this like one of those trick questions?
Well, it is a little trick.
I think they
Aren't gonna do the math?
I think they're the same.
Did I give you too many? All right, so the question is, do you, for 30 days work, you take the $528,000, which is an unbelievable amount of money for 30 days work, agree? Or would you take a penny for the first day, and then the second day you get 2 pennies, and then the third day you get 4 pennies till you get to the end? So take the pennies or take the lump sum? Yeah. Pennies?
They're the same.
They're the same? Yeah.
Is it pennies until you reach 500?
No. It's 30 days worth of work. So I'll give you I will double your penny amount every day.
What was
Does it
the
stop after 3 days?
All right, let's look. So here's first day. Agree? Run out of knowledge in my head.
Is you sure?
What?
I don't think that the 128 adds up to 560 if you double.
Okay. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 days so far. I don't know. Is that 528 looking pretty good?
No.
528? I don't know. Let's take a look.
Come on.
So how many days was this one?
A million. 12.
We're at 12 days? Okay.
You're just gonna be our new math problem.
I'm just asking you a hypothetical question on exponential growth. So 13, 14, 15, after 16 days, we're here. So $726.80. Yeah, I mean, you have to add that all up. Well, we're not, we're just barely probably over $1,000 at this point at 16 days. Sure you don't want that 528,000? Oh, you do? But I'm not even over. So 16, 17, 18, 19. Here's my 20th day. $11,468.80 you make on that day. That's a pretty good daily rate of pay.
Are you like adding all of those up?
Yep, you would sum it all up. So right now that would be, you're close to 20,000, maybe a little over 20,000. 20th day. So we have 10 more days to go. You still want that, or you want the $528,000? There's the 21st day. $22nd day. That's $45,000, isn't it? $91,000 for the 23rd day of work. extend the page. So that's the 24th day, right? 21, 22, 23, 24. $183,000 for that day? I don't know. Is it going to get there?
Wait, what was the big number?
183,500.
No,
512,000.
Yeah.
Look at that. On the 25th day, $367,000 you made that day. $734,000. Oh, look at that. On day 26, you're way above that 500,000. That's day 26. Day 27. $1 million on the 27th day. That's only the 27th day. You would add them up, yep.
So that's
That's 28, 29, 30th day.
because people are dumb and they don't think about it. It's like, well, I get a penny a day, and it like multiplies each day, but I get like 5 million or something. So it obviously doesn't like it.
So on that 30th day, you're picking up. Wait. 1, 2, 3 here. 1, 2, 3. On that 30th day, $11 million that you made on that day. So I'll ask you again: do you want to double the penny for 30 days, or do you want the $528,000 lump sum?
Double penny.
So this is a valuable question. This is a valuable question because, you know, we all dream about, oh, if I won the lottery, I would do blank, right? We've all had that thought, yes? You get advertising that you have, oh, the Powerball's now at this, or the state lottery's now at this, right? Yeah.
Well, whatever it's at, there's taxes.
Oh, I understand. So let's say you are in the running to win $123,000 or $123 million in the Powerball. Let's say you win. Okay, is that a lot of money? I will tell you, you will not work a day in your life, nor will your kids, nor will your kids' kids, unless you're really foolish with your money. Going, yeah, I'm just going down the road, just throwing money out the sunroof, and just watching people jump in front of my car or behind my car to pick up money. But the state or the Powerball gives you two different options. You can take half as a lump sum, or you can take it each time, which if you take it each time after taxes, you're getting about 2/3 of what it's worth. So after taxes, one way you get half of it, so 60 million as a lump sum, or you can get 2/3 of it, which is close to $100 million over 20 years. Which way do you take it? Do you take the lump, or do you take the 20 years where someone is managing your money and they send you a check? There you go. It's probably every year. Which is still a good check. You get that check in the mail, you're like, woo, right? So what do you think?
Wait, you're getting a check every year for 20 years, right?
Yeah, you get the same amount of money every 30. Can I borrow your calculator? A little tiny one.
That's so nice.
So let's talk about this. So this lump sum, you're getting $61,500,000. And this guy over 30 years,
This is a real thing that they actually do.
this is a real thing. So this is how much you would get if you took it over the 20 years. So, no.
Was it worth losing $20 million just to pull out the ribbon?
Well, it depends how old you are. Like if you're in your late 70s.
All right. So if you chose to get the 2/3 of the sum after the 20 years is up, you're still coming out with $82 million. Seems pretty good, because the taxes are gonna hit you. They're gonna hit you, but with quite a few taxes. Okay, hey, you want this bunch of money? Oh, you can afford to pay taxes. You're like, oh, wait a minute. Okay. So after 20 years, you're getting $82 million. So you're getting $4,100,000 a year. Each January 1st for the next 20 years. Or you're walking out with $61,500,000 as a lump sum. Which one do you think? Yeah.
I take the 20 years because really, who's gonna spend 61 million within like a short amount of time? Like 4 million does me good for a year.
4 million?
For like 5 years.
No, I agree. I mean, 4 million is a great amount of money for the next 20 years, and hopefully you saved a little bit, because hopefully you live beyond that 20 years. That 20 years is going to be a fun roller coaster, right? Yeah.
What about inflation? Because you see your money just decreases.
Ooh, I like your thinking. You're going to be an accountant. That or a stockbroker. You are a wise man. So I want you to think about something. If you got that big old check for $61,500,000, you're probably going to buy a couple of homes right off the bat within the first year or so. Wouldn't you think? You buy your sweet home wherever in this area that you'd like. Probably buy one up on the beach. Probably buy one up in the mountains, right? You agree? I don't know where, maybe you go buy something there in the Bahamas. I don't know. I'm just saying. I'm not trying to debate you on it. I'm just saying these are a few things you might do. So of that 61 million, you probably dropped in that first year probably $10 to $11 million buying those first few things. What do you think? I mean, I know some people are like, dude, I'd go get this Bugatti. Okay, you're $500,000 in. Okay, you still have 61 million to go. Yeah, but I'm just saying. I buy a Lamborghini. Okay, that's another $300,000. Then I get this Tesla. Okay, now 150 more. So you'd probably spend your first year buying the things that you want to buy right off the bat, about $11 million in. So that gives you $50 million to sit on.
You invested.
I would totally invest it.
That way it doesn't
Make a business.
inflation.
So some people, there's all kinds of different thought process. But I will tell you that the stock market, within a year, has grown 40%. Meaning if you had $50 million in there, that now is worth way more. Okay, you have $50 million in there. So now your $50 million turns into $70 million after a year. Just if it had been sitting in the stock market. But that still has your $11 million worth of stuff that you already paid for. I don't know, now you're at $81 million in cash and assets, or I'd give you $82 billion over the next 20 years. Which way are you going? And Armin says something really, really, really intelligent. That's really out of the box thinking. What about inflation? So the dollar is not going to be worth what it was tomorrow as it was today. Okay, the dollar goes up and down. There's inflation. Okay, people are like, oh sweet, we got $15 an hour for minimum wage now. Well, you know what that did? It raised the prices of everything else. Oh no, it didn't. McDonald's still has a dollar menu. Yeah, but they reduced the size of the portion. Okay, you see how you play that little game? So is it worth? I would definitely take that half up front and let me worry about it. Okay, yeah.
Is that because over 20 years, like if something ever crashed or changed like dramatically, like your money would still be worth something if you had it with you instead of paying over a certain
I guess you could think of it that way, yeah. You could think, okay, I'm not responsible enough to manage my own money, therefore I will allow this. So this is what the lottery people really want you to take the 20-year annuity, because that money now is sitting in their account, making interest, and then they pay you out the exact same amount each time.
They don't dump all the money on them.
No.
Well,
So two different things. Go ahead, sir.
okay, well, because some people like don't know how to spend their money, right?
Okay.
So they'll go and spend that 61 million like right off the bat,
Yeah.
and then within a year to 5 years, they just grow. You know?
No, I agree. There are some people who are very bad money managers.
Yeah. So like if you do that over 20 years, like it helps you manage your money better, and so that you're not like spending as much.
I agree. Well, it might be better for some in the long run. I think personally for me, I'm going 61 million. And I'm not even going to question it. Jake?
When your money sits in the bank, it like increases over time because like they're holding it, so a certain amount gets added for them holding.
Yep, you get interest built on your money. Now, unfortunately, interest in the banks right now is pretty darn low. It's like less than 1%, which is pretty cruddy. Okay? Yeah.
So someone gonna put like half of the sum like the whole like one time. You could easily spend it like all at once, or if you go for like the 20 years, each year you can invest in something different, but need something useful that you would need a different life.
They're all valid.
Yeah.
The answer is different for everybody. And I would hope somebody in here is lucky enough to do this, to win the lottery. Now, I'll tell you, I got a 0% chance of ever winning the lottery. Because I don't play. Jake?
So couldn't you ask for that 61 $500 million dollars? So you could ask for that in gold, right? Because if you ask for it in cash, then you would only be able to spend it in America, and then the value would go down in the American bill around the world. So if you got that in gold, then you can spend it.
So, well, I agree. So they would give you American cash up front, and then now it becomes your choice what to invest it in, which gold, I'd say that'd be okay. I mean, I can't imagine that they're going to find a whole plethora of gold someplace in the world going, oh, look at this. Now gold's going to drop to like 3 cents. You know, it's like, copper penny. People are like, dude, this is nothing. I mean, that might be a very wise idea because it's going to maintain and it's going to continue to grow.
Because you can't spend that American dollar now.
Right, but you have enough ways that you would be able to transfer that money to other things, right? There's people. I used to work with a guy who his job was buying and selling American and foreign currency. So he'd watch the stock markets go, you know what? I'm going to buy, this European thing for this much. And he'd hold on to that amount of money, and he'd watch the European market, increase. Then he'd go and sell it. And all of a sudden, he'd make money off of it. So, because they all,
Just capitalizing off inflation.
inflation or something really cool happened in a country that really helped their gross domestic product and went up. Yeah.
I mean, either way, if you would have chosen to spend into like invest in a company, you could still receive the same. You could still receive big enough profit to pay off what you're spending.
I agree. I mean, there's all kinds of wonderful things. We could talk for days on ideas of what to do. Now, so this is on a smaller scale, which sometimes it's really hard to fathom the hundreds of millions of dollars that we're playing with. So it says you invest $100, you get 10% interest each year. So that means that if you put $100 in this account, and this is an unbelievable account, but how much would you have after 10 years? So first thinking, so you have your $100. What's 10% of 100? $10. So after your first year, you now have 110 bucks. What's 10% of 110? That's first year. What's 10% of 110? 11. So that means that you have $121. Somebody have a calculator? What's 10% of 121? 12.1. What's 12.1 plus 121? Someone with a calculator. 131.1. That's after your third year. Oh, it's 133.1? Okay. What's 10% of 133.10? 1331, right? So 1331 added to 133.1? 146 what?
4-1.
What's 10% of that? Add 146.41, add 1464 to that.
161 and then
0 what?
5.
Okay. So if somebody were to tell you, hey, if you put this $100 in your account 5 years later, it's going to be worth $161.05. Sound good? I mean, that means you put $100 into account, you walked away, said, I'll be back in 5 years, and you came back saying, I got 161 bucks. Yes, there is inflation. But the inflation amount is not that.
Less than.
It's far less than that. Yeah, it's about 3% conservatively. Okay, if you were to take the summation of all, now, if you take a segment of time, inflation is more or less, depending on time, but if you look at the whole grand scheme, about 3%. What do you think? So, and so I'm just telling you this. If you, let's say birthday comes showing up, grandma and grandpa, or aunt and uncle, or mom or dad, say, here's $100. Let's say you really got a really great birthday, and you're like, I got everything I really want right now. So if you took that $100, knowing in 5 years you'd have 161 bucks, would you be willing to do it?
If you're not going to spend it, then what's the point of just holding on to it?
Right. If it's sitting in your little piggy bank in your room or in your sock drawer in your room, is that money increasing in value? No, it's. You open up that drawer going, oh, still got a $100 bill here. Come next year, still a $100 bill. Come next year, still a $100 bill. Right? So is it doing any good in your sock drawer? Or wherever you keep your money stash? I'm not trying to rat out your guys' secrets. So this is a exponential growth. Does everyone see why it would be growth? It's increasing, right? Okay. All right, so let's think about this. So they have an equation. You might not be able to see it real well. And on your sheet might be a little dim. But this is the equation, same equation that's there. Y equals A. A is a certain amount. It's your first amount, your $100. And then this is talking about when things are growing. So we take our rate. What was our rate on that last problem we just did? 10%, right? So 10% written as a decimal is what? 0.1, 0.10. So how this one would work, if you take your 100, your initial amount, right? Everyone still with me? Take my initial amount, 1 plus the 0.10, right? Isn't that what we set up above? 10% is 0.10. Yeah. And then T is time. T is time. Okay? What do you think? What do you think? Is this kind of a... Get this thing to load. It's thinking. So, what is the math that takes place here? What is 1 plus 0.1? 1.1? Okay, so if I did this math right here, I get 100, 1.10 raised to the 5th, right? All right. I don't want to deal with that. I want to deal with those. All right. So let's talk about the math. Okay, get all that out of there. So what did I have on that equation? I had 100 times 110, 1.10. I'm going to raise that to how many years?
5.
$161.05. It work? Hey, Ren, you got an earbud in, buddy. That's kind of rude. Okay? So, does that work? Is it a growth equation? Yeah. We started out with this. After 5 years, we wound up with this. Now, kind of a cool rule with this is 10%. Something called the rule of 72. Okay? It's used a lot. If you talk to business people, you talk about the rule of 72, everyone knows what you're talking about. So if you go 72 divided by your interest rate, that would be just about how long it would take your money to double. So if I went 72 divided by 10, I get 7.2. So after 7.2 years, your $100 at 10% interest is double. Huh. I could double my money in 7.2 years? Inflation's not quite as much. All right, so let's take a look at this. The inaugural attendance of an annual music festival is 150,000. The attendance increases 8% per year. So are we talking about more people? Are more people coming if you have an 8% increase? Yep. Yo.
I have a question that kind of related with the math problem.
Huh?
Like if you had $100 in the bank, and like let's say after like 2.5 or 3 years you wanted to put more money into it.
Oh yeah.
Like if you put like $50 more, would it be that plus the 10%? Like
Yeah.
would it be the 10% of the 50 and the 100?
Uh-huh.
Or would it be okay?
So let's say after a year you had $110 in there and you put 50 more. Now you have 160 and that's going to be 10% of 150. It's going to increase from that year on. Okay. All right, so my inaugural, so it increases by 8%. So 8% is 0.08. Agreed? Okay. So you have right in exponential growth. Okay, so y equals, how many people are we talking about? 150,000 people. Okay. 1 plus r. Well, my r is 8%, which is 0.08. And then raised to the t value. My exponent is t as in time. Okay? How many people will be at the festival at the 5th year? All right, let's do the math. So I have 150,000. 15,000, one more. Times, what is 1 plus 08? 1.08, right? 1.08. And we're talking 5 years. So after the 5th year, your first year, you had 150,000 people there. Your second year, you have 220,399 people there. Holy cow. Because it was 5 years. 5 years. Wow. That's a big venue, right? If you're going to have a concert, first off, you have a concert with 150,000 people showing up. That's one big concert. But if you have a concert where 220,000 people are showing up, you might want to order a couple more porta potties. I'm just saying. Yeah, Woodstock, you got it. Let's see. All right. Same idea. Let's talk about decay real quick. So this means it's depreciating in value. So again, it's the exact same equation. Whoops. It's the exact same equation, but there's one little difference. So now we're subtracting our r. Okay? So you're subtracting it. So you're getting a less amount each time. So So that's the exact same equation that the growth was, but rather than adding the rate, because it's decreasing, we're going to subtract the rate. All right, can we move on? All right, so we knew this is the equation, y equals a, 1 minus r raised to the t. Okay, so the value of a car is $21,500. I don't know what kind of car you are. I'm just saying that they have some arbitrary. It loses 12% per year. So 12% as a decimal is 0.12. Agree? So watch this. Ready? 21,500. 1 minus 0.12 raised to the t. What's 1 minus 0.12? 0.88. Is that right? So that means that each year your car is worth 88% of what it had been the year before. So it's losing value. How much is this car going to be worth after 6 years? So I had plugged 6 in right there. Okay, so if you did your calculator, 21,500 times 0.88 raised to the 6th power. So that car you bought that you thought was worth so much is worth $9,984.69 if you round to the nearest penny. So your car loses value. Now here's a hard thing with kids. Yeah, but if you have that car for a certain amount of years, it's going to start increasing in value. Right. If you put it in your garage and you wipe it down with a diaper each day, yeah, it will. If you drove that car for 25 years every day, I hate to tell you this, but your car's not going to last. Yeah, but it's going to be a classic. Yeah, it's going to be a piece of junk. Because you're driving it around. I mean, you find these guys, man, I got a Ferrari. It's got 417 miles on it. It's worth $280 million. Great. Sits in your garage. So I'd like you to take a look at just page 33 for your homework for tonight. Page 33. It's only one side. There's nothing on the back. See if you can play with it. See if you can have some fun. Make some higher level decisions based on that. And if you owe me a test or a quiz, you need to come see me, please.